Welcome everybody. Hope you all enjoyed lunch. We're here doing afternoon breakout sessions, doing advancements in T&D tech. I'm Dylan Lockwood. I'm senior editor at Zpryme, but more importantly, these guys are here to talk about transmission, distribution, and the technology that is affecting those things. So I'm going to give everyone an opportunity to introduce themselves and the work they do. And so, yeah, we'll just go right down the line.
Yeah, can we close the
Thank
window?
you, good afternoon, everyone. Khalil Mohammed, the Senior Director of Digital Innovation and Transformation Office. Long title, but I lead our innovation group at NYPA that focuses on clean energy technologies, R&D, and Agile Lab, which is the Advanced Grid Innovation Lab for Energy, which I'll talk about later. And we also are working on a very completely off-topic area, which is bringing fiber to the home in underserved, unserved communities too. So we're looking at innovative solutions there as well.
Good afternoon, Omar Al-Juburi. I'm a partner with EY. I run our power and utilities technology consulting group in the Americas and spend most of my time working with utilities in the US, Canada, implementing technologies around their real-time operation systems. But we basically cover the verticals from generation, transmission, distribution, customer, and kind of everything in between.
Hi, I'm Khalil, Shalabi, Executive Vice President of Strategic Initiatives at LCRA, right here in Austin. We focus really on the strategy overall for our company, but also on technology strategy. I think that's what I'm doing. And full disclosure, I used to work at NYPA.
Excellent. So, Khalil, I'll start with you. Starting at a sort of high level, what informs your investment decisions for technology, especially like on the transmission side? What are the criteria that you look at LCRA?
Yeah, that's a good place to start, Dylan. I was talking to our transmission planning folks that are here in the room, and I'm like, what promotes investment, in our system? And there's two types of investment, capital and O&M. ERCOT is a region that's growing very, very rapidly. You have technologies such as dynamic line ratings, where you're trying to eke out a few megawatts out of an existing line. That really doesn't work for us. By the time we deal with landowners, we get permits, supply chain issues that everybody's dealing with the load growth that we're having. We just want to put iron in the ground. So when it comes to investment of technology, it's not really on the capital side. We also in ERCOT have a very robust capital recovery mechanism. On the O&M side, however, that's where technology may pay off for us. So we focus there on efficiency, looking at things to increase safety, better cybersecurity. That's where technology sort of pays for us. So, if you look at it from that point of view, we stick on that side.
Ali, what about
I think it's a little different from Texas. I know we talked about this, but majority of our projects that we do are mostly for 1,000, especially in all the transmission, the new transmission lines that we are building and upgrading our 230 kV to 345 kV. Just because all the renewables coming in. Then if you look at from a strategic standpoint, we have our Vision 2030, and the fundamental question that we ask is, does any project or technology that you're looking at, does it align with Vision 2030? And then one of the pillars that we have, the priorities that we have is in transmission, growing, becoming the developer, the builder of transmission to address congestion in upstate New York, bringing the power all the way down to New York City where the actual load is. So there's a lot of variables that we look at, and from a recovery standpoint that Khalil mentioned is, we have the FERC recovery, we go through the rate base, and then, from an O&M standpoint, it's all fixed with the other utility members, but we also have a separate bucket of $40 million a year that we can invest in new technology. So we actually have more flexibility in looking at technologies and being an innovative leader.
Yeah, and Omar, when it comes to the tech component, what are you seeing that's changing utility investment strategy?
Yeah, a lot of focus on sensor technology, right? Kind of providing eyes and ears into the grid, even the transmission level, and not just kind of the traditional sensors, but things like wireless power line sensors, cameras, fault indicators. And really kind of the change over the past few years are a couple things. One is making sure those sensors, are kind of self maintaining in terms of they get their power right off the power line instead of having being, powered by fossil fuel generators or even solar or wind. And the other is kind of the intelligence that's built into these sensors to really be able to look at, things like conditions for icing on the lines, right? Or cameras that can detect signs of wildfires or remote areas much sooner than the utility or even the general public would detect that. So we're definitely seeing quite a bit of focus on that within utilities. You have a couple of utilities, you have Excel, that is implementing a lot of this kind of, new wireless, advanced wireless sensor, power line sensors, where they're really looking at trying to manage congestion and in turn providing more available capacity on the lines. And they're looking at it in the sense that they're going to use the available capacity to be able to accommodate more renewables. So that's their kind of their means of trying to defer capital investment, which is where we're seeing a lot of utilities follow suit to to a certain degree based on their strategy.
So you're going to get a little more specific. What are some promising technological investments that your respective organizations have taken on or worked within to improve grid operations? Start with NYPA.
There's quite a few. Starting with DLR, I mean, that's something that's not favorable for Texas, but for New York it is. We have a few pilot projects going on for DLR. Looking at real time. How can we, being dynamic. Looking at the temperature. Looking at the solar, the impact of that. Where we're looking at other areas as well. About one area, not looking at technology as a whole, but integrating AI, ML into everything that we do so far. We built the Integrated Smart Operations Center in 2017, where we monitor all of our assets. I would say almost all of our assets at this point. We have approximately 115,000 data points coming into the ISOC. Constantly keeps monitoring through GE Predicts, keeps monitoring the health of the asset. Any anomaly gets detected and raised up to the engineers, the data engineers that then coordinate with the site. So we have already seen that our initial investment was $16 million, but over time, the past 5-6 years, we have seen a savings of, it's a avoided cost of $43 million already. So there's a lot of technology that we're looking at. One of the ones that I want to talk about is the Agile Lab. It's just not showing, yes, where is, there's new technologies that go on, but are they truly tested in a lab environment that will function within the thresholds given? So NYPA invested in the Advanced Grid Innovation Lab for Energy, where we built the real-time simulation model of the electric grid. For us, generation and transmission are the focus, but we have an aggregated load for distribution. We're actually transitioning into our digital twin, which is the real-time simulation, using time series data, so you can predict and go 100 years down and say, what are some of the investments we can make today that can help us for 2030 goals, 2040 goals, 2050 goals. But maybe 5 years down the road, you can go and do an analysis again and say, oh, in 2023, what if the current scenario was applied in 2023? What pivots can we make? So there are definitely a lot of investments we're making in, and I think the Agile one is definitely one big one that shows, from residential level all the way to generation, what is the impact on any new technology coming in, and those technologies can be tested in the lab before it gets deployed.
Excellent.
And if you ever get a chance to visit NYPA's 8th floor where the ISOC is, there I booked about 20 tours for you now. So.
Actually, the lab is moving. That's a 300 square foot facility. We're actually moving to Albany in a 10,000 square foot facility. So we're expanding.
Yeah. But as far as technology, I will double down on what Omar said. With transmission, you travel long distances to get to different facilities. So any sort of technology that can reduce the amount of travel time that your workers are going, whether it's engineers or whatnot. For example, we just demoed a technology. It's called a point cloud terrestrial laser scanner. So if you say you build a new substation, you can put this scanner sort of on a tripod. It'll scan the inside of a room, so inside of a substation. From there, it creates an automatic 3D model and a 3D database of sort of what's in that room almost immediately. The trick is now to get that data into some sort of planning or design software, like a lot of you probably use AutoCAD in your transmission or distribution systems. So that's what we're piloting now, some software that'll get sort of that 3D model into that design software. Maybe we can talk a little bit later about how technology is implemented. Sounds really cool, but kind of the practicality of it eventually. But those are the types of technologies that for us are meaningful. What's meaningful about that is you can build as-builts automatically. As-builts are really important, but they're sort of at the tail end of a design process or a construction process. And in the as-built drawing you built today is maybe the one that some, craftsperson will use 5 years from now. And it's really important for that to be accurate. Because if they're going to identify where their line is, a breaker is, whatnot, that's all according to that as-built. So it becomes a safety issue too. If you can reduce that engineering time, reduce that engineering labor, and really focus your engineers on what matters, as opposed to this sort of broke type of stuff that's still really important, that's where sort of the economy is coming for us.
So Omar, we've been very transmission forward at the start. So what are some advancements that we're seeing on the distribution side that are changing the landscape?
Great question. So really the whole idea is kind of defer, delay, and sometimes kind of avoid capital investment, right? Investment in infrastructure. So on the distribution side, you see the kind of the introduction of flexibility type programs, whether it's obviously where it makes sense from a cost recovery perspective, where there's a mechanism for cost recovery. So you see things like demand response. Been around for a while, but if you look at, Con Ed, for example, that has a very advanced demand response program, had it for years and continued to grow it, and they've worked it out with the regulator that it kind of makes sense in terms of the balance of investment. You have kind of non-wire solutions, right? And again, I'll use Con Ed as an example because they really are quite advanced in that, where they're kind of focusing on purpose built DERs to manage congestion, provide flexibility. They've enrolled 25,000 customers last year, voluntarily opted, about 400 megawatts. This year they're going to double that, so they're shooting for 50. Those are big numbers, right? It creates quite a bit of flexibility for the utilities to be able to manage congestion and so forth, and really avoid some of the capital investments. You have things like FERC 2222. If you want to talk about market mechanisms, transactive market mechanisms that are going to come in place. It's been around for a few years now, but the market rules are still being figured out. The whole idea is really around DER aggregation and being able to play in a wholesale market, the ISOs and RTOs. And in New York, California, they're kind of leading the pack. Now they're coalescing around a 10 kilowatt being the minimum size of a DER to be bid into the market. We're going to continue to see more and more of that as transactive markets going to come on board. There'll be a lot more investment, a lot of focus from utilities as well as third-party players around the market, just like we saw in the wholesale markets, in the mid '90s and late '90s and so forth. So there are several of those kind of flexibility type programs. However, there's also investments in hard kind of infrastructure that's needed. So things like feeder reinforcements, right? We know that with the electrification that will continue to happen, you need to be able to provide more capacity, more power, strategically in certain places. And that happens with things like feeder reinforcements that allow utilities to be able to address the needs of the community, whether it's the proliferation of EVs or other DERs that are going to require to support from the utility that they don't have today. So it's kind of a combination of these programs. Underlying all of this are really investments in technology to make sure that, at this stage, whether it's on the T side or the D side, it's a data game, right? It's making sure that, the utility has the data to be able to make decisions that have business relevancy in real time for all these programs that exist. So there's a significant continued investment in technology to be able to manage, enable all these programs.
Yeah, and that data infrastructure is very key to digital transformation across the utility industry. We've heard a lot of unique challenges with digitalization of lots of aspects of the grid, the generation side, the customer experience side, the NERM side, all that stuff. Are there digital technology challenges unique to this aspect of the business? And if so, how do your organizations typically take those on? We'll start with Will.
Yeah, sure. Maybe using an example is the best way to go about this. But I go back to the fact that for a transmission company, you're covering lots of ground. So a lot of us are starting to use drone technology for line inspections. I know NYPA does a lot of this. We talk to you guys about technology all the time, so imitations. Ice phone flattery here. And so we've been doing that. We do it across lines that are sort of hard to access. If the line's crossing a river, instead of sending some person out in the boat to do that kind of inspection, maybe you can do a drone inspection. You need to keep line of sight. And then sort of now you get all the data. We're talking about data. You get hundreds of images. And what do you do with those? Typically what happens is a supervisor sits down and starts looking through photos. And that just takes hours to figure out, okay, is this an anomaly or not? And then this kind of looks like an anomaly. Let me now send somebody out to verify that this is truly an anomaly that I really have to do something about. So the Shangri-La is, we'll feed this into some sort of AI program, which I think we're testing the same program right now, both of us, so we'll have to compare notes. But then the program has to do sort of the same thing, right? It has to figure out, this is a bolt. First it has to recognize that this is a bolt. And then it has to recognize this is a bad bolt or this is a good bolt, right? And it's over and over to all these thousands of different anomalies that have to happen to replace that human in the loop, a person that has 20 years of experience that can look at a photo and say, that doesn't look right, right? So I think that's a challenge when it comes to sort of acquiring. You can acquire the data very quickly. So in this case, the data is a photograph, but then what do you do with it? I think we're still on that next step as an industry. We can acquire data really well. How we process data, I don't think we're very good at that yet. But we may be getting it.
And Ali?
I was gonna continue on the same path with data, and I was gonna talk about the drones since you already talked. I'm gonna touch there, but with respect to data, we embarked on this whole digital transformation years ago, 7 years ago, and the first thing that we realized was the quality of the data that we had. Being a utility, when we did our DQI, which is the data quality index, I think for our assets, which is our bread and butter, our data quality was at 69%. And this is a fact. I mean, when we got the results, we were like, this is something has to be done. It took us 2 years to get to 99%. And it was a lot of effort from operations, all the people in the field validating the data that we entered is accurate. Now we have protocols in place where if you don't enter the correct data, the system automatically generates a message to you asking you to go fix it. If you don't respond within 2 weeks, the regional manager for that area will get a notification saying that your employees are now working on fixing the data. So data is very important. The other thing that one of the challenges we see is, you're talking about images, you're talking about video, now you're transitioning from on-prem to the cloud. Talking about cybersecurity, and I think that's one of the big areas where NYPA is investing in, whether it's intrusion system, whether it's, even from an employee standpoint, people working in the field and stuff, inside a threat. There's a lot of investments we're making from a digital transformation perspective in cybersecurity. So there's definitely a lot of challenges. Two were the top I just mentioned.
So when it comes to investing in technology, we talked about various goals that for doing so, security, resilience, reliability. How are investments in T&D technology affecting or helping implement utilities' sustainability goals and targets to that effect? Which I'm sure utilities all have sort of different ways of approaching that, but I'll pass it right back to you, Ali.
Well, it depends. I mean, looking at, from a sustainable standpoint, what are some of the metrics that we were tracking, and and this is a change that we made recently with Vision 2030 is, reporting up to the board as to what are some of these goals and how are we achieving them. Some of it can be achieved with technology, but some of it has to be done internally, whether it's internal process optimization. Not everything gets answered by technology, but automating your workflows, digitizing some of the paperwork that you still do in the field. There's a lot of things that we have done where it's a journey. It's not a sprint, right? So it takes time for us to get to that end stage, but we are inching closer to those goals.
And Omar, where are you seeing the investments being made? Where are the priorities?
Yeah. I mean, sustainability is a very big topic, right? So there's from a regulatory perspective, there's the reporting side, which a lot of utilities are starting to do. But really, if you look at how do you translate actions into sustainability, right? It's automation that is going to impact sending crews into the field, impact kind of the carbon footprint that you're creating as a utility. Automation through technology, automation through optimizing your business processes. Doesn't have to be just technology. So we're seeing a lot of that as an improvement in sustainability as a byproduct of a lot of the technology investments and the standardization that utilities are going through. So just kind of going back to technology, one of the biggest challenges that utilities face right now is really around rationalization of technology, whether it's platforms, it's vendors, it's whatever the case is, because there is a lot of it out there. A lot of it is data driven in terms of the need to get more data, better quality data, and like Khalil said, we figure out how to use it, because now we almost have too much data. Then you get all these different platforms to really build, whether it's to manage your day-to-day operations, forecasting, whatever the case is. And the utilities are very known to just kind of pretty much have every technology you can think of a utility will have. So kind of rationalization around how you're going to invest in your technology. Who are your kind of vendor ecosystem players that are going to be with you the next few years, invest in you, and so forth. I mean, that eventually will drive sustainability, because the whole point of technology is to automate, reduce manual work, reduce truck rolls, reduce a lot of the things that historically the utilities do that contribute to your carbon footprint or kind of adversely contribute to sustainability.
Khalil, anything there?
I think there's probably two major ways transmission utilities can help: reducing congestion and enabling interconnections. And that's sort of bread and butter for utilities. Typically, renewable projects are, in a remote place and load centers, away from load centers, and that's where a transmission utility can be helpful. Bring that congestion and not have interconnection queues that are 3 years long. We have an advantage in ERCOT because we don't put sort of the interconnection financial obligation on the generation entity. So our queues tend to be a little bit shorter than other ISOs. Probably something to consider in other ISOs that have had a lot of issues with developers sort of putting in multiple queues or multiple spots because they're not sure whether they'll get picked or not, because the queues become just really long. I think that's sort of the two major ways that we can.
Excellent. So let's talk about implementation. You brought it up before. So what are some barriers to reaching the goals that you're setting out with these technology investments, and how have your organizations strategized to work around them? I'll toss it back to you, Khalil.
Yeah, sure. Actually, my group, we have quite a robust process on how we pick technology investments. Because it can get really disaggregated. You can have multiple groups throughout the utility that want to do sort of maybe sometimes the same investments. Knowledge doesn't transfer very well, but a lot of our investments go through sort of a central group. We do business cases. We have a multidisciplinary sort of high-level council that votes on whether investments are going to be done or not. We have a pretty rigorous piloting system to pilot technologies, and you don't want your piloting system to be too bureaucratic. That's where you sort of want to fail fast and get things done, figure out is this right for me or not. But having sort of an upfront strategic process that determines where you're going to invest your money ahead of time, I think is crucial, because it avoids spending a lot of money in different places that are redundant or wasteful. So we have small buckets of money for new technology, and really want to spend them in a good way.
And Ali?
I mean, everything Khalil said, right? And we do have a robust R&D department that works with communities, and some of our customers are municipalities, and state-owned buildings. We don't supply to residentials. So when it comes to piloting the technologies, we have a better chance of partnering with some of our municipalities because they're forward-thinking. The other thing is, especially when it comes to your vision. Making sure, for Vision 2030 from NYPA, if a technology doesn't align with Vision 2030, that's the end. We stop it. Even if we have already made some investments at some cost, that's fine. We'll just eat that cost and move on to the next technology. And I think that comes from the culture from our leadership. And once you have that culture built into your organization, embedded deep into your roots, into your DNA, I think you'll be very successful with that.
Thank you. Anything to add, Omar?
Yeah, no, I think Khalil said it well. I think the only thing I would add, when it comes to technology, there are a few key things to figure out. What are you going to do in-house versus go outside, right? I mean, that's a key determination because it's a balance. You don't want to build a lot of stuff in-house, obviously, because at the end of the day, you're not a product vendor, you're a utility. But you do have some uniqueness that it has to be accommodated, and you have to do that in-house. The other is really around having that partner ecosystem, like I said before, of product vendors and others that are going to be with you through the journey. A lot of the technology we're talking about is fairly new, so most products and product vendors out there, it's not a mature technology. You have you have the kind of area in place where you can influence the roadmap for that vendor, and in turn, really have the product be built to meet your needs. So that's kind of something to consider up front. And then rationalization, like I said, there's a lot of products out there. You don't want kind of every 31 flavors of technology. You want to kind of settle on your core set of vendors and technologies that are going to take you into the future and really be able to influence the roadmaps of those vendors.
Always appreciate a 31 flavors reference.
They're still around, right? That's more obvious.
Yeah. Good. So I do have more questions in my notebook, but I wanted to open it up a little bit early for some audience questions because there's a lot of you. There might be some. So.
Yeah, good question. Khalil, you were saying that LCRA covered a very large expanse of territory, and the assets cover a huge swath of Texas. We were talking about intelligent edge systems and drones and all this data collecting capability. How are you reconciling the massive footprint with all this data production? Are you aspiring to collect this data at some point real time through some sort of private network, or are you currently collecting it in batches as these drones land, or as somebody goes out and downloads the data from these sensors, or what's the thought process there?
I mean, there's a lot of different types of data. To answer one of your questions, we have our own fiber network, so we don't rely on public networks to collect data. Different data go into different repositories. If it's maintenance data, we have Maximo, which a lot of utilities have. Drone data goes into its own sort of repository. One of our biggest databases is our GIS database, and a lot of stuff kind of lands there. One of the things we're trying to do is kind of get all these groups together. So we do have a sort of nascent and up and coming data governance program. Trying to get folks together to figure out, first of all, identify where's all the data, maybe do the data quality check you did. I hope we get to 70%. Where you're 69? Yeah. So we'll be at 70%. Whether we are or not, we'll be at 70%. And you know, and then really sort of, we also have these data stewards in every single department. They meet, they get together. So having that sort of data governance program going forward, I think you want to start from the governance perspective to the process perspective before you kind of merge all your tech and your data points together.
Can I just add one thing to it, just to add on, and we embarked on our data governance and the whole data management side as well a few years ago. And we have a data governance committee that meets monthly. That's where all the stewards come together and talk about what are some of the data sets that need to be monitored and controlled, right? So we built what we call Amazon shopping cart, where you can go on a central page and request for data. So now you have different roles. You have data custodian, data stewards, data users. So the user can go in and request access to data, explaining why they need access to it, and it gets approved through the process. So it's, you know, yes, we're collecting tons and amounts of data, but now you don't want to congest your network as well when you're requesting all these data, right? So there's a point where we actually build the system platform out to our employees where I can go in and request a set of data and have to wait till it gets approved by the data owner and the data custodian. And then once it's approved, then I get access to the data. And the other point was, you know, from a drone perspective, yes, it's right now we're just collecting the drone or the data from the drones itself, but we're also looking to build our own private LTE network. So we can have beyond visual line of sight drone program where we can have real-time data coming in. We actually piloted that during COVID in December 2020 with Nokia, where we flew a drone on 600 megahertz spectrum with real-time HD quality video and thermal imaging up to 4 miles. It had to be done line of sight, so we could only go up to 4 miles from our where our antennas were set.
Thank you for the question. Did you just get approved for non-line of sight drone?
We just did, yes. So it's like, you know, steps, and it took us 3 years to get to that point, but yeah, we're inching closer to it.
So, question for the panel, it's been fascinating. Talk to us about success metrics on such projects, because in the end, it comes down to how do you measure success systematically?
I mean, there's different ways you can look at it, right? You know, look at different KPIs. If you're talking about general digital transformation that I was leading is what is the adoption rate of technology? That's a success point. If you look at, say, an ERP system upgrade, then you can look at, okay, are there any efficiencies that you have gained going through the process engineering phase, so you don't duplicate the same mistakes that you were making before, right? Or you know, you have a backlog of things. How are the backlogs being addressed as part of this new process? So there's different ways that we can look at it. I mean, it's a broader question, but I believe that there are success metrics for everything that you do with an organization, and I think it's important for the leadership to see what those success rate, the criteria are, and what are the metrics that you're reporting out. Are the investments that we're making, should we continue to make those, or do we need to make any changes?
Maybe I'll add to that. I think it's a good question. Made me think, Christina, we need to come up with success metrics for it. But we've been focused on the upfront. What technology has been costing us and project completion rates. We haven't really figured out sort of the back end. You know, what's the result and what does success mean with the result? So we've been kind of focusing on the upfront part for now.
And I don't mean that as a rhetorical question, right? So, for example, just speaking on the thermal images part, right? I'm talking about the incremental value added of the thermal image of a transformer vis-a-vis manual inspection. So this cost for the data acquisitions, at what point of time do we say the differential diagnosis is not worth it?
So we help a lot of utilities, a lot in this space in terms of the business case for these things. And it's kind of similar to, Volvar optimization, for example. Model-based versus real-time enabled through, a power flow. Is it really worth the investment? How do you measure the incremental value? It's similar because at the end of the day, data has to support a specific business process or a specific function, and you have to be able to measure the incremental value from the status quo, right? And if you're unable to measure that, then it's kind of a pet project from IT. They want to put in a shiny new system and collect a bunch of data and put some new servers, all that stuff. So it's that. And by the way, we're seeing less and less of that happening now, right? I mean, everything has to go through the business case and justification, measurable, metrics around the increase in whatever efficiency, reduction in cost, whatever it is to justify the investment. So that's no different. Having said that, there are kind of R&D type, actions like drone technology and things like that, you're not expecting a return on day one. And you all, as a corporation, you have to make sure everyone's on the same page that I'm not going to see a return on day one, but it's worth the investment from an R&D perspective, because if I do a pro forma or a forecast, year 3 or 5, whatever, I'm going to start seeing a return on investment, or it's needed from a reliability perspective, so I have to do it. Just like you're in an energy management system on the transmission side, there isn't really a financial business case for it, but it's reliability, you have to do it.
I just want to just one point real quick is, when you have a business case, especially when you're working on innovation projects, it's hard to justify against something that's, you're doing a repair for the asset, you're repairing an asset or something like that. So we have to stand up there, and I'm the guy that actually stands up there and justifying why we should be making an investment. It has to be tied to a problem that you're trying to solve, that there's no solution out there that exists within the organization, and you're committing to dollars that you're saying, this is something that by the end of, say, 5 years, 4 years, whatever the timeline is, that we will see a solution that will help address that problem. So I think, we come up with hundreds of projects too, every year, but, maybe a handful of them get approved from the committee. So we do have a robust process that we have to go through the business case and then get to the approval from our executive leadership.
Yeah, I do think business cases are important. I think it's important to put your thoughts and your numbers down on paper, but I'd like to see the innovation project that gets approved based on the business case. I mean, they're all going to be sort of in negative territory. So I think what's important is to have an approval process to begin with, so you don't have those IT kind of projects. And second of all, is to have visibility and the ability for multiple folks to sort of look at the decision and vote on it. Right? I think you need sort of a collective experience of the people in the room to figure out, is this a good idea or not? Because the business case, I think, is important, but it's, there's going to be a lot of business cases written and a lot of technology projects not done if we just go on.
So as we're deploying more data-driven assets, how is our workforce changing to better maintain some of these assets? We're collecting all kinds of data. We've got fiber, radio. How's the workforce? Are we adding more SCADA techs, more network engineers? What does that look like?
We're adding more vacancies.
I mean, I would refer you to my 11:15 session on Gen Zs and the whole digital workforce. But we see a change, right? One example I would say is, when COVID hit, not every employee had a cell phone, and it was hard for get in touch with any of them. So one of the directives from the CEO was issue a phone to everyone within the next 15 days. It was done. But union employees, they think that you're tracking them. So they don't want to use the phones. There's like 400 phones that don't even turn on. So we have the generation gap, and there's going to be a gap until we have, whether it's the Gen X and the millennials that are getting used to digital transformation and all the technologies coming out. It's a process of going through that change. But when it comes to Gen Z, it's the opposite. They want to rely on technology for also, like ChatGPT now, right? So you can pass bar exam now with a newer version. So it's about, what age group you're in and how tech savvy you are and your ability to actually adopt the change and adopt the culture for digital transformation.
Okay, so I love this discussion because you're touching on the idea of having to justify by business case your projects that may be innovation, maybe piloting, whatever you're doing. But at the same time, like Khalil's saying, is that sometimes you have to shift your mindset to fail fast. Reconcile that for me. Go.
Yeah, don't fail with $1 billion. I mean, yeah. I mean, I think you said it is you need to have that fail fast bucket, but it's a budget. You know what it is, and you're okay losing that. And then other real investments have to go through a fairly rigorous, approval process. But bifurcating your budget to allow for that type of technology innovation, I think is important.
And we do have a budget that we go through. We call it loosely DevOps. It's truly not DevOps, but this is just for us to pilot things at a really smaller scale without going through the approval process. Once we know that the technology works and functions and it's addressing something that we're looking to address, then we build a full business case. For us, it's a little easier from recovery standpoint. So for us, innovation, projects could easily be approved because there's a FERC order that helps us recover some of these costs. So it's easier to justify. At that point, you don't even need a business case, but we still have to show the value and the benefit it brings to the organization. So it's a different mix, but sometimes you have to choose, which, what are you fighting for? Are you talking about just proving a point for a technology to be implemented, or are you looking to address something where there isn't any recovery to it? So, it's a gamble there.
Thank you. Anyone else?
What do you guys see as the most disruptive technology in the next 5 years or so? Each of you.
You start. So we can just repeat what you said.
I mean, I don't think our industry is really going anywhere. I think disruptions will come more from sort of the regulatory and economic side than from the technology point of view. So, and those are important too. I mean, those typically sort of reflect the will of the people and where they want our industry to go. But I think that's where most of the threats will be. But I mean, we're transporting, millions of megawatt hours every year. We're not going anywhere. For a while, there was a death spiral and DERs and whatnot. But you look at, for example, a rooftop solar program at Austin Energy. It was a very robust program. But at the end of the day, the amount of megawatts installed just failed to what just one transmission line can do. So, yeah, it's just economies of scale and networks. They win.
I think there will be disruption. I think the whole decentralization triggered by DER will happen. Probably not in our lifetime, to be honest with you. I mean, it's going to take. You're good.
That's what the Gen Z said.
But I mean, eventually it will happen if it's dictated by technology, by economics, and so forth. The rate at which it will happen is probably a lot slower than what we were led to believe a number of years ago. But it will continue to happen where there will be decentralization. There will be more focus on kind of a whole microgrid type concept, self-supporting communities, whatever the case is. The utility is not going to go away, obviously, because you still need the utility at the end of the day. Their role may change a little bit in terms of being the backup as opposed to the first line. But again, that's not going to happen tomorrow. I think other disruptions you're going to see, especially when we get into transactive markets, if and when we do, if the regulatory framework is there and so forth, are new players like we saw in the wholesale market, third parties that are going to be, the utility is going to be competing against, excuse me, to play the role of aggregators. That's definitely going to happen if there's money to be made, which, if there's a market mechanism, there will be money to be made. So that's something that's coming down the road, that if utilities want to play that role, be that nimble to compete with third parties, that's a game changer. That's a disruption that they need to.
other than legislation, policies, everything they talked about, when it comes to technology, I think AI definitely would be one where, utilities will start investing in more and more. The whole, and like I said, it's machine learning process, right? It takes time for it to understand and learn the operations of the utility industry. When we looked at, looking at, our assets, especially of a transformer or a breaker, there's not enough operations on the unit where you can apply AI ML today. I think a collective action with all the utilities sharing data and having enough data sets to even apply AI, I think would be very crucial. But we're not at a stage today where we can do that. So, from a technology standpoint, I would definitely say AI ML the next 5 years would be the strategy.
What's that clock over there say?
0.
This is 0. All right, I guess we're done then. All right, thank you all for joining us today.